This is Declarative Spinnaker, presented to you by the Council of Robs, which is us. Here's the council. I'm Rob Zienert. I'm a software engineer at Netflix working on Spinnaker, and Rob Fletcher, also on the Spinnaker team. Let's see here. What we're going to talk about today is just a brief history of Spinnaker, why it is the way it is, why we're interested in declarative in general, the landscape of declarative in open source. You guys can read. Keel, and then the future, and finally we'll finish with some Q&A. So, get a little boring stuff out of the way. In case you guys aren't totally aware of the difference between declarative and imperative, imperative is really defining how you want to get to your desired state, and declarative is I want my state to look like this, and please get me there as quickly as possible. When you're doing imperative, you have to define how you're going to be validating that a particular asset has been released correctly. You need to be able to define if in case any part of that release process goes wrong, how to recover and roll back. Whereas declarative, if something goes wrong, you can just set the version back and it will reconverge back at the desired state. So Spinnaker is today entirely imperative, and that's primarily because of Asgard, the system that predates Spinnaker at Netflix, was the system that everyone used. And it was a lot of knobs, quite like this. Actually looked exactly like that. A lot of manual, imperative toil, lots of knobs. Everyone was able to kind of do exactly what they wanted to, driven mostly from customers knowing exactly what they need for a deployment, and they know best. And imperative also allows a lot of flexibility. We're able to develop a single feature, like say a deploy stage, and then people can implement it with different strategies and that kind of thing to kind of fine tune it for their needs. So that allowed us to get a very wide adoption and very quickly with not a whole lot of effort from our side. And people were able to kind of self-discover what best practices for delivery were out there. So we didn't have to actually dictate to anyone, you should deploy your software in such and such way. So why declarative at all? Oh, I don't have any speaker notes. So, speaking of toil, a lot of people are now getting to the point where they don't really care about all the knobs. They don't care about the specifics of getting their software to production. They just want to get to production in the safest and fastest way possible. So in a declarative way, if you say, I want to have my production system look like this with this version, we can introduce best practices behind the scenes without people necessarily having to concern themselves. One of the biggest problems at Netflix today is we are continually iterating on what is the best way to deploy to production. Maybe we do canary, and then we introduce something like squeeze testing to figure out like right sizing, instance sizes, in order for people to kind of stay on track with that. It's a lot of cat wrangling, and it's really hard to do that, coordinating across thousands of developers and that kind of thing. And people just kind of get fatigued with it and eventually don't do it. So by defining things of just, I have this desired state, we're able to, as a central team, iterate for people what the best practices are. And it also gives a better rollback story, because we're able to store hermetic state, and when we want to go back to the previous version, we know exactly what that was, and we just roll back. So the declarative landscape today, there's more than this, obviously, but CloudFormation and Kubernetes are for Spinnaker kind of non-starters because they're cloud specific. We can't really use CloudFormation internally for Spinnaker because not everyone's on AWS. Similarly, not everyone's using Kubernetes. We don't use Kubernetes. But with like Kubernetes CRDs and that kind of thing, there's some affordances for being able to share things there. And then Terraform is obviously the most popular player out there. It's got a good DSL, it's got great documentation, wide cloud provider support, but it has two kind of cons. One is the three-way state management. So you have this TF state file that you have to keep around, and if you lose it, then you're kind of in a bad spot. And then the other one is that it's primitives only, so there's no higher level abstractions, there's no best practices. It just does CRUD operations, and there's nothing to kind of help along with a red-black scenario or any of that kind of thing. So, did anyone go to Pim's talk about Declarative yesterday? Spinnaker for Borg. Yeah, Pim went. So, if you guys are interested in what they are doing, there's this handy little survey. But basically, we've been collaborating on what Declarative means for Spinnaker. And we'd be very interested in continued support out of Google. It's been phenomenally helpful for us to kind of learn from what Google's been doing, and they've been doing Declarative for a very, very long time, whereas it's relatively new for Spinnaker. So being able to kind of get a jump start with everything that they've known has been phenomenally useful. So now I'll pass it off to Rob, who will talk about far more interesting things.
Hi. So Keel is the declarative microservice that we're building right now for Spinnaker. This is our implementation of a declarative delivery system. You can already look at it on GitHub. It's already part of the Spinnaker open source organization. I want to talk a little bit about our kind of design goals around that, and then dive into some specifics at a fairly high level about how it works, and then where we're taking it from here. So the design decisions we've made so far are, it's going to be a plug-in model-based system. What this means is that the fine-grained details of how assets are modeled are opaque to the central annealing service. It doesn't know or care about how a security group is defined, or how a cluster is defined, or how a version of software being delivered to a server group is defined. All it knows is, does this thing have a hash equally to the existing state? If not, I need to update it. We would like to use gRPC for transport and protobuf for our APIs and representing the state internally. The reasons for making that decision are, I don't know if anyone, hopefully everyone heard Boris from Mirantis talk this morning about Spinnaker in his keynote, and he raised a very good point about Spinnaker's pluggability is maybe it's not its best feature today. We are trying to address that concern somewhat with Keel, and with the hope that we can develop something that we can broaden out to other areas of Spinnaker as we go forward. Internally at Netflix, we have gRPC is quite a big thing in our platform these days. We also have a lot of teams that are not using the JVM stack. Spinnaker itself is a JVM application. Most of it's written in Java or Groovy. Keel is written in Kotlin. But not everyone at Netflix uses the JVM. We have an awful lot of Python, for example. gRPC gives us a kind of language agnostic, or protobuf specifically gives us a language agnostic way of modeling things, and we can export an API, a strongly typed API, as opposed to the kind of random jumble of JSON that a lot of the existing Spinnaker APIs use, that can be consumed by people using various different languages. JVM, Go, Python, just about anything out there, I believe. Many people in Netflix are using gRPC already. Increasingly, like the Titus API is completely based around gRPC. So, you know, if this looks familiar from Pim's slides yesterday, there's a reason for that. There was an early implementation of Keel that was making good progress, but didn't embody a lot of these design constraints, these design decisions, and we kind of went back to the drawing board a little bit after some really good in-depth discussions with Pim, and we're driving forward on a kind of V2 of Keel that's very inspired by the stuff he's been doing. So let's take a look at how it actually works in theory. So the annealing engine is the kind of core of Keel. It takes assets in over gRPC, so an asset could be a piece of infrastructure, a version of software that you want to go out to your cluster. It could be, you know, a load balancer, all these kind of things. There's a very wide spectrum of things it could be. We're gonna import that by gRPC, store it into a repository of desired state. Then we are, you know, where can that asset come from? It could come directly. I don't really think asking people to write protobuf stuff directly is ideal. So we want it to be pluggable at the front end. So we're going to put a REST API in front of it. We imagine a lot of people will be scripting against this API. Hopefully, I think Newt integration is a really strong possibility. If anyone doesn't know what Newt is, it's Netflix. I can't even remember what it stands for. Workflow Toolkit. So a lot of people in Netflix use this to kind of bootstrap their applications. I think if we can have that thing generating the assets that will get pushed into Keel, that makes an awful lot of sense for people. Because one of the itches we're trying to scratch initially is around initial setup of applications, which Spinnaker doesn't have a great story around today. If you have homogeneous applications, which increasing numbers of teams at Netflix do, around kind of setting all of them up to look the same, and especially replicating that into different regions, into different AWS accounts. And, you know, when I do on-call rotations, one of the frequent problems that comes up is, oh, something doesn't connect properly in this particular environment, and when you dig into it, it's because, you know, ingress rules are configured slightly differently on security groups or that kind of thing. Whereas if we can standardize that and allow people to have a homogeneous rollout across as many accounts and regions as they need to, that kind of problem disappears, hopefully. So we'd like it to be pluggable at the front end for getting the data in there. You know, if that means we're reading YAML files out of your Git repository at some point, that would be a really interesting possibility. But the key thing, as I talked about earlier, is that, you know, those assets are composed of two parts: the metadata, which says what type of asset it is, what other assets it depends on, and the asset spec itself, which is completely opaque to the annealing engine. It just treats that as a blob of binary data that it will be able to compare hashes of, fingerprints of, but nothing beyond that. It doesn't introspect that data at all. And then, you know, when it detects a difference, it will talk to plugins designed to communicate with different clouds or different, you know, whatever you can imagine. The primary ones we're working on obviously are EC2 and Titus. So it will be able to instruct those to get the current state of this particular asset, or go make the asset look like this. We also have and those things under the hood, you know, the existing ones we're working on right now, we'll be just talking to Orca and CloudDriver. So for reading the state, they will be speaking to the CloudDriver API, fetching the state via that, because, you know, this is a solved problem to some extent. We have a lot of good tooling around that already. There's no need to reinvent the wheel. And also talking to Orca to actually actuate those convergence operations. So you'll be able to see Keel doing things in your tasks view of your application in Orca much as you can. If you're using Chaos Monkey right now, you can see Chaos Monkey killing your instances in that same view in the same way. So you'll see tasks appearing there, which is Keel operating on your, converging your desired state. Another concept we have is veto plugins. So the idea is here, very similar to something Pim has, where it's you know, a bunch of plugins that can, for various reasons, give you yes, no, go ahead, go, no go decisions about a convergence. So that could be for a variety of reasons. One of the obvious ones would be, well, somebody else has messed with this resource and it doesn't look like what it looked like the last time Keel knew about it, so we should probably not go stomping on that existing resource. Another could be, well, this team only wants to roll out changes during work hours, not on weekends, not in the middle of the night when there's nobody available to deal with pages or nobody that wants to deal with pages. So execution windows, like you kind of have in deployment stages right now in Spinnaker. Applications may want to just turn this off, would be another obvious example, and say, actually, for the next foreseeable period, we don't want anything converged. We have a critical problem we're dealing with, and we'd want to manage it imperatively. A variety of other things. So that can be anything. So I keep forgetting my clickers aren't actually plugged in. So let's look at how that annealing engine actually goes about doing its work. So it'll read all the assets out of that repository. What is the current state of that asset for which it will talk to a specific kind of plugin? One of the pieces of metadata it can read about that asset is what type of asset is this and what plugin is responsible for dealing with that type of asset. So it'll go and talk to that asset and say, fetch me the current state. Does this match the desired state? If so, fine, let's move on to the next one. If not, let's go ask all of the veto plugins, am I allowed to update this right now? If not, go back to the next asset. If so, let's converge the state. And for that, we'll talk to the same asset plugin again, the same one as over here. So pretty straightforward, I think. And we're just going to run this on a schedule. So it'll check every so often. I don't think we've really pinned down exactly how often we'll need it to check. Right now, we might get some more sophisticated scheduling involved later, but there's no need right now, I don't think. So that's kind of how it works. So what does this mean for the future of Spinnaker? I think the key point to make here is this is not intended to replace the imperative Spinnaker that you know right now. It's intended to be complementary to it. We are trying to, as I said, the first itch we're trying to scratch is that initial infrastructure setup. So one of the first things we want to do is dog food this within the Spinnaker team itself for setting up our ELBs and our security groups and that kind of thing. Because right now that's kind of a pain point for people. We have increasing numbers of teams who manage a whole bunch of apps at once, and they want them to pretty much look and behave the same way or be configured in the same way. And right now that means a lot of clicking back and forth between apps in the Spinnaker UI and configuring things manually, potentially a lot of copy and paste of JSON, which is nobody's idea of a good time. There is a big push within Netflix right now to broaden the number of AWS accounts we're using for security reasons. Traditionally we had like prod and test accounts and a separate account for billing related things that are under regulatory restrictions, but our security guys want to broaden this out, so there are more dedicated accounts for different applications and different application groups and areas. So this need for let's roll out something homogeneous into a bunch of different places at once is increasing. There's also potentially, as Netflix has gone global over the last couple of years, potentially we might be looking at new AWS regions at some point. Right now we use 3 of them, but there is every chance we could expand that at some point in the future. We already have the managed pipeline template system that manages some kind of homogeneous management of delivery of things, but it's still fundamentally an imperative system in which you describe how you want things to be delivered. So it feels like a natural fit in some ways, but this is not doing away with managed pipeline templates. Managed pipeline templates will absolutely still be a thing. This is complementary to that as well. What I really would like to see is more opinionated options for delivery delivered via Keel. So right now we have the standard options of Red, Black, and Highlander, and we have custom strategies for delivering a pipeline, but it's kind of very restricted to the scope of what do you do around creating and enabling your new server group. There's only so far you can take that. I'd like to see things like canaries being brought in there. So if you want to have a canary before you deploy your new software, let's just have that be a convention over configuration option in Keel, where you don't have to think too much about anything except I want to use these couple of metrics. Rob mentioned squeeze testing as well. That's a really interesting option where we can try and help teams make decisions around right sizing, or in collaboration with the traffic team at Netflix, we can help people make decisions around right sizing their server groups, so we're not spending more money than we need to on running Amazon instances, and we're not at risk of things falling over due to load. So I'd like to see kind of more opinionated options around that at the front end, which is why we're looking at this pluggable model at the front end. Keel itself would be storing extremely fine-grained details of how everything needs to look, but that shouldn't be what the user needs to worry about unless they have very specific requirements that are like outside of the 80% use case. So we'd like to layer a lot of opinions on top of the declarative system. There is, obviously, talking of the future, there is a lot of potential synergy with what Pim and Google are doing here. If they do make the decision to open source, I can see us adopting some of what he's building in order to help us build declarative in Spinnaker. So this looks interesting. When can you use it? Our approach is that we're taking things fairly slowly. We want a good, robust solution here, and not like the quickest thing we can build out there with a horrible API that we then can't make changes to easily. Like I said, our first goal is let's get Spinnaker itself dogfooding this. We also have, so we're aiming for security groups and load balancers very soon to be managed by this in Spinnaker itself. We also have some teams one team in particular at Netflix that's really interested in scaling policy management. They do this as a centralized service for other teams and help other teams make decisions about scaling policies and metric tracking. And there's no great story around that in the Spinnaker UI, so declarative seems to be a really good fit for let's build some way of managing scaling policies in a declarative way. We have a team using an older declarative system called Atlas Deploy, and we'd really like to bring them under Spinnaker's wing. They want to be delivering things in a declarative way, so we need to do some work on kind of making sure we're hitting their use cases and giving them an adequate replacement for that existing system. Declarative is going to be a major push for Spinnaker as a whole throughout 2019. I anticipate a lot of work being done on that. We'll see a lot of evolution of it. I don't want to make too many promises about timing, but keep an eye on there's a Slack channel in the Spinnaker open source Slack. Please reach out to us on that if you have thoughts, input, reasons why what we're doing is dumb or wouldn't work for you. And with that, I'm going to wrap things up, and we'll open up for Q&A.